and that's caputRecorder, which has been changing fairly rapidly over the last month or so as I learn how to do this kind of stuff, and as people come back with suggestions for improvements. Right now, I guess there's 3 installations of this out on, 2 on Beamlines and 1 in an X-ray lab, and that's a good thing to do because those guys had some good suggestions. Anyway, caputRecorder is support for recording and playing back EPICS puts. So any menu selection that you make in MEDM, or any text entry field that you write to, or any communication at all that comes from outside of an IOC and affects an EPICS PV, that's a caput, and you can record all of those. This also functions as a user interface for executing Python functions. So if you have both of those capabilities, you can record those caputs as a Python function, then you can execute that Python function, and basically you can automate anything that you know how to do manually. And this is what the user interface looks like. Here you specify the function name or the macro name that you want to write, and then you push start, and then you do whatever you do, move motors or program scans or execute scans or whatever. Then you press stop, and when you're done, you will have something that looks like this in the macros file, except that you'll be able to see it because the font will be much bigger. So this is the file that caputRecorder writes. And you can do anything you want to with this file. You can edit it, or you can switch it for another one. So if you switch to a different experiment, you can have a different macros file for each experiment if you want. And then to execute, you select the macro that you want from these menus. Each one of these gray boxes actually can hold 16 macro names. And after you select the macro, then you just push do, and it'll just do whatever you recorded. It'll just do it over again.
Can a macro call another macro?
Yes. You can record a macro calling another macro. I'll show you on the next screen, actually. So if you start recording a macro, let's say we write a macro name in here and then press start, you can, while you're recording this thing, you can select a macro, and if there are arguments, you can fill in values for those arguments, and then you can press do. And when you do that, it's not going to record all of the caputs that result from that second level macro, right? It's just going to record the fact that you made a function call to that macro. So it turns off recording, in other words, while that function is executing, and then it turns it back on when the function is done. And you can do this any number of levels, right? You can have a macro that calls a macro that calls a macro that's... You can have a macro that calls itself. Not directly, but you can, yeah. So it's software. It's powerful and it is dangerous. So how this actually works is that the IOC side intercepts caputs and it publishes them to an EPICS PV. And the way that works is through access security. That capability already existed in EPICS. Every caput that comes in from outside the IOC, and only outside the IOC, goes through access security, and the idea of it is to decide whether or not the user has permission to do that caput in the first place. But there's another use for it. There is the ability to trap that write. And so if the access security rule that governs that caput has the attribute trap write, then the information from that put will be sent to any registered trap listener. And caputRecorder is a registered trap listener. That used to be what it did. And that got us into trouble that Kurt discovered the very first time he tried to run caputRecorder, is that you write to a motor tweak field, and before caputRecorder gets a chance to read the data, it's already been changed back to its default value. And the problem was that the trap listener didn't get the actual value that the user wrote. All it got was the PV name. And so it had to go scrounge around in the database and look and just grab that value straight out of the record. Well, that's too late, because that's after the record has finished processing, right? And by that time, that value has already been put back. So Andrew Johnson modified the way access security works, and now there's a patch for at least one version of base on APS share, so that access security can send not only the PV name but also the value. And now that fixes all of the outstanding problems that I was having. So anyway, caputRecorder writes this to a string PV, and then anybody can look at it. It's this PV right here. It's this guy. And it has this form. There's the name, and there's the value, and the user at host. And that's all the information that you get. So each IOC that runs caputRecorder, or at least the server side of caputRecorder, is going to publish at least this PV. They might do all this other stuff too, but it's going to at least do that PV. So the client side, which is a Python program, monitors that PV. It might monitor several such PVs, and those are the things that it's going to record, that it's going to write. And the client side also interacts with this EPICS database, which is basically sort of a thrown together user interface for, we could have a Python user interface to do this. It would be better in some respects, but you wouldn't be able to use it as a client API, right? The advantage of doing stuff in a database is that it's automatically available to everybody who knows how to do a caput. So that means Spec, for example, Spec already has macro, so I don't think Spec guys are going to use this macro capability, but they could. Spec can write to this PV and can push this button and can wait for this thing to issue a callback, and it can execute this macro even if it doesn't know what's inside the macro. So the users might have a stable of macros that do the kinds of things that have to be done to align something or to calibrate their monochromator or whatever. And anybody who knows how to do a caput can execute those macros. So the client side also maintains a macros file, which I showed you on the last one, in response to start and stop signals. Start and stop writing a macro Python function. And then the client side also executes the macros that are in the MEDM display. So when you write a value here, or when you make a selection from one of these menus, which ends up writing a value here, and then press do, it's Python, it's Python, or caputRecorder.py that's actually running, listening to that, and it says, oh, all right, well, I know what I got to do now. It goes into it actually imports the macros file into the macros namespace, and then it will execute that function. And there also is, oh no, I'll describe that later in execution. So the other things you can do, you can add comments. This is pretty handy if there's something that you actually can't record, like if you wanted to write a particular value to some motor, for example, but there's no way to record a CA get. I haven't figured that one out yet, right? So you actually want to record a CA get, you can just type a comment in there saying the value that's going to be written really should be this value, for example. You can do that. You can add time delays if you want to. So if you want to adjust the timing of this thing, make sure that you wait 20 seconds for this thing to warm up or whatever. So recording a macro, there are some rules, and you don't have to follow them because caputRecorder is not going to allow you to write a macro name that isn't legal in Python. It'll just fix it. It won't complain about it or anything. It'll just fix it, mostly by replacing offending characters with underscores, and it'll trim it to 25 characters because that's all an MBBO record can hold. And it also has to start with a letter. So you don't ever have to worry about that. And when you're done recording, Python flushes and closes the macro file, and then it reloads that. And then by reloading, what it actually does is it writes all those values again. It clears all these menu fields, and it writes all the values that are now in that macro file to this. But the problem is MEDM can't automatically update its menu fields. It just doesn't have that capability because at the time MEDM was written, EPICS didn't have the capability to tell anybody that menus had changed. So what you have to do, it's kind of a pain, you have to press refresh menus. So to select a macro, it's pretty simple. You can either do it using menu PVs, just click and this thing will drop down. I'll show you how this thing works later. You can see it happen. Or you can write, as I said earlier, you can write to this PV right here. Either one of those things that'll have the same effect. And then caputRecorder will fill out the fields, the arguments, if there are any arguments, and give the default values of those arguments. So as recorded, their macros don't have any arguments. But the very first thing that I wanted to do was to actually parameterize a recorded macro so that it could apply to any motor, say, or to have different values. I would have a macro to start a scan, but I wouldn't always want to start from 0 and go to 1. I mean, that would be, right? So caputRecorder will show you the values, and then you can change those values. And you can edit the macro file to add arguments and stuff. I'll show you how to do that. And then you have to press reload macros afterwards. And there's a thing in Python, even in Python 3, it knows how to reload a module, but it doesn't know how to delete anything from that module. As far as I can tell, there's nothing in Python that really knows how to do that. And so the workaround is just to restart caputRecorder. And that's pretty easy to do. You just push this little button up here, and it just restarts the Python program, which opens up the possibility of having more than one of these things running at a time. I did that, and it was great. It was hilarious because there's 2 clients monitoring all these PVs. Both of them are trying to write to the same macros file. So you don't want that. So now what happens is on startup, caputRecorder.py writes its start time into an epics PV. And from then on, it monitors that epics PV. And if it ever gets a value that is different from what it wrote, it assumes that must be some new guy in town. I'm out of here. And so you'll only have 1 copy. I used to do this the way we do it with start epics, by looking at by using the PS command to figure out what processes exist. And that's okay. And that worked up until caputRecorder 131. That's the way this is done. But that's just not good enough. And it turned out there was a lot of ways for me to fool that guy into thinking, including just having 1 extra space in the command. It won't recognize it as a thing. Yeah, it's just not a very good way to do it. This is much better. So I want to get everybody up on 1.4 as soon as I can so that I don't have to worry about problems because of having two copies of caputRecorder running at once. That's 2 copies of caputRecorder talking to the same database. You can have, if you have 2 databases, you can have as many copies, you can have 2 copies of caputRecorder that are completely independent. That's not a problem, right? They can have their own macro files. You could, for example, have 1 copy of caputRecorder that really only executes blessed macros that were written by Beamline staff, and you're not expected to do any recording. And there would be another caputRecorder that's in there for the users to do whatever they want to do without worrying about trashing the Beamline maintained. So I don't know whether that's going to happen or not, but that's one of the possibilities. Oh, and about pressing refresh menus. I did find a way in Epics to figure out whether the user has pressed the refresh menus button. I can't automatically, what refresh menus does is it closes this MEDM display and reopens it, right? And that gets the values of all those menu items because those happen when a display opens. So I can't do that automatically, but I can write this little text down here, this red text that flashes and tells you to press refresh. So when caputRecorder knows that it has overwritten those menus, it will make this thing blink, and that will continue to blink until the Epics database recognizes that that the client list has changed. What it does is it monitors the mlist field of, I think it's an ASUB record, and there's a little dot here that actually represents a monitor onto that record field. So it looks at the first 5 elements of that mlist field, and those are the pointers to events. This is how Epics actually sends monitors to clients that have registered. So with the first 5 elements of that list ever change, then it will assume that you've recycled the MEDM display, and it will turn that annoying thing off. But if you have 2 copies of this display, it will turn it off on both of them. and they won't necessarily both have been refreshed. So that's all the further I can go. That's all I know how to do. So to play back a macro, you just press do after you've already selected, right? Or a client can write to that field and also press do. While you're executing a macro, you can abort it. And what happens in that case is, first of all, Python just interrupts the execution of that thing. But if it's done any put callbacks to write to motors, for example, or to start scans, there isn't any way automatically to know that those things have to stop. So the other thing that the abort button does is execute the _abort function. Let me show you in the macros file. I don't know why I'm showing you this. You're not going to be able to read it. But so as delivered, the macros file comes with an abort function, and its first character is an _, which means it's not going to show up on any of the menus. So when you import a file in Python and then you do a dir, those _ functions won't show up in that directory listing. As delivered, this thing just stops all the motors and stops all the scans, and it stops a particular scalar. And that's probably not what each beamline is going to want. So what you really ought to do, if you ever intend to abort a macro, you should modify this abort function so that it does all the abort things that you might have to do. It might stop a multi-channel scalar, for example, or you might have two of them or whatever. All right?
Are you saying it's like hits the all stop?
Yeah.
Okay.
Yeah, it's the all stop button and the scan abort button, and yeah, and you can hit anything you want. Okay. So that's the abort function. You should edit it, and you can add your own private macros in there. If you have some little routine that you don't want to expose to the users, but you actually want to use that in your own edited Python code, you can hide it from the users by beginning it with an _. So there are a number of configuration options. I'll show you a picture in a minute. You can select which users you want to record from and which workstations. And you can also select which IOCs you want caputRecorder to monitor for CA puts. So those three things you can change at runtime. And one of those things you can actually change in access security, but I'm not going to go into how you do it. It's listed in the documentation in some detail how you do that. But that's basically an access security thing, not a caputRecorder thing. So you can specify the users that you want. And if you specify any particular users, then that means everybody who's not named is not allowed to, is not going to be recorded. Or you could specify users that you don't want by prepending a minus sign to the name. And if you do that, then it means everybody who doesn't have a minus sign in front of their name is automatically allowed. You can do either one of those things. You can do both, but if you have a minus sign in there, the minus sign governs. And you can specify the IOCs. And this just allows, or this tells caputRecorder which IOCs to monitor for CA puts. They're going to publish their CA puts no matter what you do, but you can listen or not listen to them. So there are some other options. You can record the timing of the puts. And Epix will do, or caputRecorder will try to do as good a job as it can. But it's going to, by default, it's going to be doing put callbacks, right? So it's going to wait at least as long as it takes for the operation to complete. And then it's going to, and so that means you might have the timing pushed out a little bit. But you can also say you don't want to wait for completion. You can do these things while you're recording. You can say, don't wait for completion, and if you do wait for completion, here's how long you should wait for completion when you're executing each command of a Python function. And finally, you can customize the performance, what caputRecorder does if a macro already exists. It used to be that it would just fail. It would just tell you, you can't. You already have that macro, and I'm not going to overwrite it. But now you can also choose append if you want. It'll place that macro at the end of the file, and then it will just continue recording with that. Or you can replace it, and it'll erase that macro entirely, and then again, and write a new version. And if it ever does that, if it ever actually erases anything, it writes a backup, a dated backup copy of the macros file from before that, so that if somebody trashes your macros, you're still going to have them. Just because they recorded over it, you still have a copy of that. So here's pictorially almost the same thing. We got 3 IOCs in here, 2 of the bending magnet IOC, well, a bending magnet IOC and an area detector IOC and an insertion device IOC, and you don't want to record from the other beam line, obviously. So you wouldn't specify this name in your list of IOCs. And inside caputRecorder, figuratively speaking, are filters for the user and the host and the IOC. And in this case, if you don't want an IOC, it'll simply not listen to it. But if you do, if you have specified that you do want to listen to these IOCs, then it'll look and it'll see what user did that. Do I want to record that guy? And some users you just don't want to record. For example, VW5 is the user in a VME crate. You never want to record that guy because look what's going to happen. If you execute a scan, all the CA puts that might come out of that scan might come out at 100 hertz. And you're going to be recording all that stuff. You almost never want to do that. So what I'm guessing is that people will only want to record stuff that was done by a person, right? MEDM or something. So it'll be Linux machines or Windows machines or whatever that actually can do these CA puts, and you won't be listening to any IOCs. But maybe for troubleshooting, we wouldn't want to do that. I don't know. That's one of the expected uses of this, is to help in troubleshooting. So that's all I got for caputRecorder. So I found out one thing about the way this works. This is actually running up in my office on my Linux workstation. I'm just connecting to it over X, right? So if I try to edit macros, what's going to happen is it's going to open an edit window on my workstation. So in order to have that not happen, I have to restart the recorder so that it knows that it's this X window that it has to talk to. And after you restart the recorder, you'll see immediately you get this press refresh here because it wrote to these macros, it wrote to these MBBO records, and it doesn't know whether those things actually had the same values or not. So now that I've done that, I can look at these menus, and I've got a whole bunch of stuff, mostly test macros that I've already written. And we can look at those macros by pressing the Edit Macros button. This used to be a script field, but I had to change that because I wanted to allow you to have a macros file for each IOC. And it turns out that it's easier to have caputRecorder do that. So anyway, this is what it looks like. Here's the abort function that I told you about. And this is parameterized, so it should work on any IOC. caputRecorder will call this with the prefix that you gave it when you started it up. So you might want to abort scans in more than one IOC, or you might want to do all stop in more than one IOC. So you need to edit this abort if you ever want to use it. And then this is what macros look like after they've been recorded. First thing is a record date. Actually, there's no reason to keep a record date, but it's illegal to have a function in Python that doesn't have any content. So one of the things that users are certainly inevitably going to do is push start and say, oh, wait a minute, I'm not ready to start recording yet, and then push stop. And if you don't have any command in there, that's illegal, and then your macros will crash on entry, and it'll be bad. Well, it won't be that bad. You'll have to restart the recorder. So why don't we go ahead and record a macro? I'll call it Tim. And I'll position this guy at the end of the file so we can see what's actually happening. So start recording. And this has already written something to the macros file, right? Def Tim, the definition of my macro, and this record date that protects us against just immediately hitting stop. And then I actually don't know what I want to do. Maybe I should move a motor. Yeah, tweak a motor just to prove to you that that actually works. I swear, it was amazing. The very first thing Kurt did when he tested this out was he pushed this button right here. And that tweaked a motor, and oh, I'm not listening to YYY. I have to tell caputRecorder that I want to listen to YYY. So by the way, this field overrides the default choice, which is just to listen to the IOC prefix that caputRecorder is looking to for instructions. So if you want to also monitor YYY, you have to tell it your other prefix as well, otherwise it won't monitor that. So this overrides the default value. Let me get rid of that guy. So I'll call this macro TIM1, just so there's not any confusion.
By default, does it exclude VW5?
No, it doesn't do anything by default. I mean, by default, it does monitor. This is whether it puts a monitor on the IOC, right? It doesn't exclude VW5, and maybe it should for APS use. Yeah, that would probably be a good idea. So where is that? Oh, here's the macros. I'm sorry? No. No, I'm not. I'm not excluding anything now. Yeah, let me show you the config again. So for users, I'm allowing everybody, and for hosts, I'm allowing everybody. And if I wanted to exclude VW5, it would be minus VW5 here in users, right? Minus to say no. No, you know, let me show the. Oops. Let me show the help screen.
That's I'm going to trap like communication between IOCs. If you allow VW5, you're just seeing communication between IOCs.
That's right. Right, you'll see scan records and user cogs in one IOC writing to PVs in another IOC, and you probably don't want to record that. Within an IOC, you never record because it doesn't actually go through channel access. It just sort of pretends like it did.
So
But
that's not even plumbed in there, is that the capability is not there to record everything going on?
right, to record everything within an IOC. If it doesn't go through access security, I got no access to it, right? And nothing inside of an IOC goes through access security, right? So, I mean, the examples I have minus VW5, but the actual users and hosts are blank, which means everybody is permitted. And now I just changed the prefix so that XXX and YYY are going to be listened to. So there's the tweak. And as I was saying, the first time we did this, this guy showed up with a 0 in it. Because by the time caputRecorder got down to reading the value from the database, the record had already processed, had already set the thing back to 0, and we were scratching our heads trying to figure out why don't tweaks work. So let me edit that back. All right, so this motor is at 18. Let me stop recording and then replay that macro. I have to press refresh menus because this little thing is blinking again, right? So that was called TIM1. So these guys show up in alphabetical order, which is a little bit disconcerting at first. But it turns out if you have a whole bunch of these things, that's really good because then this whole display sort of acts like an alphabetical index into all your macros, and you can find them more easily that way. So TIM1 doesn't have any arguments, and if I want to do, it's just going to press that tweak button twice, and each tweak goes by 6, right? Or I could say I want to do that twice by specifying the number of times, and then it'll do that. So one of the things I've done is recorded a macro that moves a motor and then reverses the direction of the next move. Or actually, I could record a tweak forward and back and then execute that 1,000 times if you want this thing to continuously move while you're doing a measurement or something like that. A really easy way to do it.
So each one of the select menus is actually a different file?
No, they're all the same file. It's just there might be more than 16 macros in that file. So at first it fills up this MBBO record,
Oh, I see.
right? Then it goes to this guy here, yeah. And I don't know whether 6 is a good number or not. That gives you like 90, 96 or something possible macros. One use case that this was based on is Sector 4, where they do a lot of this stuff with Python and their own macros file that they just wrote by hand. And they've got like 250 macros. So I'm thinking, you know, we're going to probably run out of gas and it'll probably be increasing this. But one thing I did is I made the clearing of these MBBO fields and all the arguments. I made that happen in the database so that caputRecorder doesn't have to write 96 zeros or 96, you know, empty function names. So that's a little bit quicker.
I would say, so you can, and if you know, if you want, you can obviously, you can edit that file by hand and then reload it.
Yeah. So why don't we do that? I'll just show you. Let's see. I'll change the motor. All right. This will be a tweak. Well, actually, let me change the name too. And then I'll give it an argument. And then instead of M1, I'm going to say motor. But I'm building a string, so I have to do it like this. So is this clear? What all I'm doing? So Python's going to make a string. It's going to make y colon whatever this motor is, might be M1, M2, whatever. Then it's going to add dot tweaks, so we know we're writing to the tweak field. That's Python's way of adding strings together, of concatenating strings. I mean, there's other ways to do it as well, but that's the easy way to do it. Oh, it is?
Yeah, is it? That's it. Yeah. Java has C#.
Oh, that's not.
Okay, so now since I changed the function name actually, and let me, while I'm at it, I'll just get rid of this guy because we don't really need that. So now I have to restart the recorder because I've deleted stuff and changed the names of stuff, and that's just going to be ugly.
Is the heartbeat for the recorder or for the?
Heartbeat is for to say that the recorder is actually running.
Okay.
And now I got to refresh menus again. And now we should see this tweak. And because it has arguments, and by the way, the arguments have to be of this form. There are other ways to do arguments in Python, including just by order. You can just have the name without any equals whatever. But caputRecorder doesn't handle that because it can't show the user what those arguments are, what the name of the arguments are, and give it away. So now I can change this. I'm not going to tweak motor 1, I'm going to tweak motor 2 instead. So I better bring that guy up. So now when I execute this guy, it tweaks motor 2, right, twice. So just what you'd expect. Then caputRecorder will fail to reload it. And you won't be able to use it until you fix the error in the macro file. I haven't found a way to really make that obvious. But you'll see it in the window that originally started MEDM. So let's see, I guess what else should I do? I should also have a macro in here called motor scan. And it's all set up to use XXX motor, so I'm going to get rid of these guys. So this macro programs a scan record to scan this motor and to read from the scaler. And by default, it scans motor M1. So if I do this, all we're going to see right now is, I guess we should also look at the scan record and see what it's doing. Uh-oh. How did I do that? This is really strange working on a Macintosh. See, so let me do that again. I mean, it's going to do that scan twice. Well, it doesn't look like much because these are actually simulated motors and they're a little bit flaky. But you can see that it actually did run the scan. So now I can record another macro. I'll call it TIM2. That first is going to move motor 2 to 20. And then is going to execute motor scan on M1. And I'll just leave the default arguments in here. Yeah, maybe I shouldn't have done 20. It's just waiting too long. So now I don't actually have to select this, but I'm recording what I do. So I don't want to rely on the fact that motor scan has already been selected. I want to actually select it. And then I'll only do this once. So now this scan is happening and it's not recording anything. It's only recorded the fact that I executed that macro. So we should look at the macros file and see what's in there. I don't know why that's in there. No, it's TIM2 is the one that I just recorded. And it looks like that was still happening from the last scan while I was recording this thing. So anyway, what I did on purpose was to record moving motor M2 to 20. And then this is the result of executing a macro while you're recording another macro, right? It just grabs those arguments from the MEDM display, or actually from the database, and it calls motor scan. So let me get rid of this guy because I don't actually need it. And restart the recorder. Oh, I didn't have to restart the recorder. Oops. Oh, I added an S. Oh, it's control. So that's what happens when you have an error in your macros file. All right, so now if I select TIM2 and execute it, It's going to move this. Oh, this guy was already at 20, but now it's going to do that scan. So let me move this guy to 19. And then do this again. Oops. So it moved the motor and did the scan.
How did it know to wait?
I'm sorry?
For that motor to finish its move before it starts?
Oh yeah, I should have. Where's my? Here's the Python code that does that. This is what's recorded by default. So I give it the value that I do a PyEpic CA put. I give it the PV that I want to write to, the value that I want to write to that PV, and I say wait equals true, which means that it will do a put callback and wait for completion, but I also have to tell it how long to wait because there's a default wait time, which is probably like a second or something like that.
Right,
But
you might, in the opposite thing, you might want to start that motor in the scan, right, right basically.
right, and if you want to do that, then you have to go into the options and specify that I don't want to wait for completion. And this is a per CA put choice, right? You can set this to no, do a CA put, set it back to yes, and then all the other CA puts that you record will be written with put callbacks, right? So as I mentioned, we also have this choice of being able to record the timing of the puts or not record the timing of the puts. If you want really faithful recording of the timing of those puts, then you would select record timing and don't wait for completion, and then it will do exactly what you did. But it will always measure time on the workstation, not on the IOCs, right? Because we know that IOCs can differ in their times by 6 seconds, 3 hours, and so using those times to do the delays is not going to work. But by default, it doesn't record the timing of the puts, and it does wait for completion, and by default it waits for 5 minutes, which is way longer than most things, but not long enough for scans, typically. And also, as delivered, this thing comes with, if a macro already exists and you say I want to record a new macro, it will just fail and tell you why. But as I said, you can also either want to append to that macro or you can replace that macro.
Where's the macro file specified? Does it start with the command file?
It's actually specified in a script file. Yeah, that's a good idea. Let me show you that. So this file, start put recorder, this is the 1.4 version of start put recorder. Those are different. This version doesn't have to worry about the fact that there might be two CA put recorder.py programs running at a time, because the database figures that stuff out now, right? So the command that starts CA put recorder is this. And, well, actually it's this. And you give it the name of the macros file. This could be a full path to the macros file. You don't actually have to specify that, and if you don't, it's macros.py in the current working directory, which would be the ADL directory, or actually it'll CD to the Python. Yeah, if you don't specify this, then you probably better CD to the Python directory. But you can put this anywhere you want, because some of the Epic's IOCs, everybody maintains their IOCs differently. Some people put all the ADL files right in the IOC application. Other people have it in some user space or in some other space that is independent of Synapse version and things like that. So the normal way to execute that in CA put recorder 1.4 is to specify the prefix that tells it which database to look at to get directions from, and then the full path to the macros file. And by the way, this macros file is actually going to be macros_xxx::py, and that's the easiest way to have to have several different macros files in the same IOC directory. You might have more than one, you know, for the B station and the A station and all that. So, and this might change because this has never actually been run with multiple IOCs out on a beamline yet. So when that happens, there's no doubt there's going to be some little glitches and stuff, and we're going to have to fix it. So some of the stuff that I'm telling you is probably not going to actually stay. But I think this should work. I think this strategy should work. So are you good with this? Okay. Let's see.
Waiting for scans?
It's the same thing. It's just a put callback because scans also don't call.
But how long?
Oh, right.
For how long? You have to actually manually change that number.
You got to change that number. Yeah, if you're actually going to do a scan, then 5 minutes probably not. Well, it might not be long enough for a scan. Yeah. So you can change this while you're recording. Most of these you can change while you're recording, but you can't change the prefixes that you're monitoring because it'll have to do a CA monitor.
Yeah.
Right? You can't do that while you're recording, and you can't change this choice while you're recording because it's just, I mean, it's too late.
Couldn't you also change the wait for how long to be either 0 or -1? I can't remember what PyEpics uses, but for indefinite wait.
Yes, you can. You could wait forever. Right. Yeah. And that might be a better default than this. Maybe I ought to do that. Because if it hangs, 5 minutes is also going to be probably too long. Yeah, I might as well. I should do that. That's a good idea. This will be out in version 1.4. 1.4.1. Let's see. What else? Anything else I should? Yeah. Well, you can already edit this Python code and do whatever you want. And I think one use of this thing is just for people like Sector 4 who have a whole bunch of macros to make it easier for users to run them. And they're never going to expect users to do their own recording. And they might even have a separate display that hides the recording functions of this thing. And all you can do is select macros and run those things and set the arguments and just run them. And that way users don't have to sit there with a book next to them that has a list of all the 250 macro commands. Right? So I think that would be kind of a good thing.
I think so. One of the use cases you might think about would be for the Mooney staff to run this while the users are there overnight, so they can just create a file that has all those inputs that they did.
Yeah, for diagnostic purposes or.
I mean,
Right.
nothing stopping you from doing that.
Right, there is nothing stopping you for just recording an infinitely long well, however long it takes, yeah, to record all the user input. And that way, if the user is trying to figure out, how come my monochromator is not at the right energy? What happened overnight? Right, this happens. This happened at 1BM, for example, several times, and it was a big mystery yeah. So, yeah, that can help you figure out whether that was an errant user calc or whether that was a user who was typing something and didn't realize that the focus mouse was in some MEDM display. That kind of stuff happens all the time, and it's really mysterious and really hard to figure out. So yeah, this can help in debugging and in troubleshooting. And one of the things I was thinking was that for troubleshooting, if you know how to reproduce a problem, and you can do those steps in one order, and then do the steps in a slightly different order or with slightly different timing, and you can send that macro file to the guy whose job it is to fix the database that's flaky. That is really a good way to send troubleshooting information out. Because typically what you get is, sometimes when I do it, it does this, and other times it does that. Well, the question is, what's different? What did you do different? Well, I didn't do anything different. I did everything the same, or mostly the same. And that's really the level of information that users normally have about what they've done.
Doing it right now, or there's an intermittent problem where I'd almost like to just put this on there and say, go ahead and run your stuff the way you normally run it, because I can't break it, with my tests. So, and I don't know what all they're doing and so yeah.
Right, I had that.
Let them run and see what comes out.
Yeah, I had a problem like that at Sector 3. It took me months to figure out how to reproduce the problem that they were seeing. So let's see. Is there any other caputRecorder stuff folks want to try or look at?
you don't have to designate, I want to record this one, this one.
No, you don't have to specify any of that stuff. You just have to say which IOC should I listen to, and yeah, put to any PV. I mean, it does depend on the access security file, but the default access security file that I'm recommending to people just does trap right for everything. So, because we don't really use access security much on the beam lines.
Right, where we run into is, like, something up display for the ID.
Yeah.
And then you get that circle with the line through it. So those would be,
Right, that circle with a line through it, that's access security telling you that you don't have permission, right? So, well, and that does bring up a good point. This is not going to be very useful if you don't have caputRecorder, the server side of it, running on the IOC that you're going to be writing to. So I've been working with Marty Smith. We've got the caputRecorder installed on one insertion device IOC in Sector 29. And I've also been working with Matt Moore and Tim Madden to get caputRecorder running on a couple of area detector IOCs that we have actually the ability to rebuild. But the as-delivered area detector IOCs, that's going to have to go through Mark, right? Because he said he's willing to add this stuff into area detector generally, so that after a while it'll just come. You won't have to do anything special to add it. And it'll also be nice in Synapse 5.8. You get it whether you like it or not. I mean, you can comment it out, but you don't have to configure anything, because it is kind of a pain to configure IOCs to do all this stuff, and it's a sort of an error-prone 10-step process. So it'll be better when we get to Synapse 5.8.
What determines the editor when you click edit macros? Is
Oh,
that the
thank you.
editor environment variable?
Yes, the editor environment variable. And maybe I should do caputRecorder editor or something like that, because people might want a different editor for Python code than they have for, they might be using that environment variable also. Yeah, I guess I should have shown you those environment. I kind of did, but I really didn't dwell much on those things. There are a number of environment variables that run this thing. Macros.py dir is one that you can set. caputRecorder.py is how MEDM knows how to execute this thing, because MEDM doesn't know about Anaconda Python or any of this stuff. It doesn't know where that is, because if you might run two different versions of caputRecorder, well, you better have the Python code that matches the database that you're running, right? So this happens automatically. You tell MEDM which version of caputRecorder to run, and this variable actually comes out of your release file, just like it does for starting up any MEDM display. So macros.py, I guess, is sort of the main environment variable that specifies the full path to the macros file.
You could run from a command line.
You could. Start caputRecorder?
No, I mean, I've run just open up a Python session and load.
Oh, yeah, you can.
Files and just do spec like, just,
Yeah, you could do that, yeah. Or with IPython, I think, probably be, I played around with that a little bit. Just importing the macros file that had already been recorded, right? And then I can do anything I want to with all those macros. And I think that is actually probably a pretty good way to orchestrate experiments for which, there's no time to write the software for the experiments. Users coming tomorrow, right? That kind of stuff. Then if we have a stable of software for doing all the little things that have to be done generally in experiments, you can just bolt those guys together in different order and support the exact instance of the experiment that they want to do. And then you don't have to actually negotiate this user interface. You can just roll your own, yeah. I think Sector 4, if they use this at all, they're certainly going to use it that way. So should I move on to, oh, yes? I'm sorry, does it come with what? A startup file? Yes, there is an example caputRecorder in the top level of the caputRecorder module. So you can just copy that from caputRecorder into your space and then edit it. And the same thing with the macros file. There's an example copy of a macros file in caputRecorder app/op/python, and you can grab that, and that'll be your starter for it. And all of that stuff is described in probably more mind-numbing detail than you want. I tend to be a little bit wordy in documentation. All that stuff is described in a recipe in the documentation, how to actually run that, how to install it, and how to use it.